Yeah. So hello friends. Today we are going to see question number 6, which is from subject operating system, and it is of one more question and it belongs to the year GATE 2011. So let's see what the question is. Now the time taken to switch between user and kernel modes of execution be T1. Okay. So let me just note down here. We have a user mode in our operating system and we have a kernel mode. And the question says that the time taken to switch between these modes, let that be T1. So I'm going to just make a note of it here, T1. While the time taken to switch between two processes, let that be T2. So let's assume a process P1, let's assume a process P2, and the question says that the time taken to switch between these processes T2. And then they are asking the relationship between T1 and T2, which of the following statement is true. So let's try and establish some relationship between T1 and T2. Now let's first focus on the concept of T1. So as we all know, let me zoom in here. As we all know that user mode and kernel mode are represented in a hardware by a bit. Okay, so in any operating system, the way we represent the current mode of execution. Okay, so the current mode of execution is represented using a bit in a hardware register. So this is some hardware register. Okay, so some bit, let's say this bit, this represents the current mode of execution. So whenever we are switching from a user mode to a kernel mode, all the operating system has to do is just replace this bit by 0 to 1. And whenever we move from kernel mode to user mode, we have to replace this 1 by 0. So the switching from modes, from user mode to kernel or kernel to user, is literally a change of bit in your hardware. It's a change of bit in your hardware. So this is going to be a very small time of execution, maybe just 1 or 2 clock cycles, because it's just a change of 1 bit. Okay, so this is our understanding of the change of user mode and kernel mode. Now let's come to processes. So this is a process P1, this is a process P2. Now as we all know that a process in an operating system is represented by a structure which is called as PCB. What is PCB? It is nothing but a process control block. What is process control block? It is nothing but a structure. Okay, a structure that is used to represent a process. Now PCB is a very elaborate structure, it's a very big structure. The data that the PCB will carry is going to be, first it will carry the ID, it's called process ID. Then it has to carry the process state, like what state the process was in, whether it was running, whether it was paused, whether it was waiting, whether it was ready. Then it has a list of register data, that what was the data, what was the data that the process was working on. Then it also has a list of number of open files, what were the files that the process, that a given process was working on, whether it was modifying the file, whether it was deleting a file, whether it was writing to a file, whether it was reading from a file, all that data goes here. So the point I'm trying to make is, this PCB contains a lot of, it's a huge structure and it contains a lot of data. Now when we have to switch from P1 to P2, whenever we have to jump from P1 to P2, what are the steps that are involved when we are doing a jump from, when we are switching a process from P1 to P2? First we have to store P1's data, okay, into P1's PCB. We have to store all this, information. It will be a huge chunk of information. So first we store that, and next we load P2's data from P2's PCB. So P1 will have its own PCB, P2 will have its own PCB, and we have to, when we are doing this step, okay, when we are doing this step, when we are switching from P1 to P2, we have to do A and we have to do step B. And when we are going to do a reverse thing, what will be a reverse thing? When we are going to switch from P2 to P1, we have to do the same things. We have to store, so we will store P2's data in P2's PCB, and we will load P1's data from P1's PCB. So as you can see that switching processes, okay, the point I'm trying to make is that when we are going to switch the processes, this time T2 is going to be a very huge time, okay, because T2 is going to be very huge, because T2 is nothing but this entire big structure PCB storing and loading. So T2 is going to be very huge as compared to T1. Sorry. Yes. So T2 is going to be a very huge number. This T2 is going to be a very huge number as compared to T1. So the relation that we can think is T2 is going to be a huge number than T1. This is our understanding. Let's see if we find this in our option. Yes, we can see option number C. T2 is very big than T1. So option C is the right answer.